Hello everyone, in Unit 7 we're going to be talking about geometry. This is probably the most challenging unit in Tier 1, so if you have any questions at all, please let me know. I could probably make 4, 5, 6, 7 videos just talking about geometry. So know that you're going to have to spend a significant amount of time in Ed Ready on this unit, so just be prepared for it. The first thing we want to talk about is angles. So the part of an angle is your vertex, which is where the two arms meet. Symbols used to represent an angle, you may see it represented this way or with the kind of arc through it. Now there's two types of angles that you need to know. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Complementary angles, you can usually look for that 90-degree box. So if you see that with two angles inside of that box, those two are complementary angles. Now supplementary angles, what you want to look for is at the bottom of the two angles, when they're combined together, you will see a straight line. So if you see a straight line at the bottom of angles, 2, 3, however many angles that are here, if you see a line at the bottom, then those angles that are above that line add up to 180 degrees. I always remember it by supplementary angles, kind of sounds like super angles. So those are the big ones. Those are 180 degrees. Complementary angles are the ones that add up to give you 90 degrees. Now, vertical and adjacent angles. So vertical angles are actually angles that are opposite from each other. So when two lines intersect, angles that are opposite from one another are always equal to each other. So we know that angle 1 and angle 4 are equal to each other, and angle 3 and angle 2 are also equal to each other. Now, when two lines have the same vertex and they share a common side, those are called adjacent angles. It says if a pair of adjacent angles forms a straight line, keep in mind they are supplementary. So take a look back at that picture over here on the left-hand side. Whereas 1 and 4 are vertical, those are equal to each other. 1 and 2 we know are supplementary, or they are adjacent angles that add up to 180 degrees. Because if you look and combine angle 1 and angle 2, look what forms at the bottom. So these two that are side by side are going to add up to give you that 180 degrees. And that goes for any of these angles that are side by side. 2 and 4 will add up to 180, 3 and 4, and then 3 and 1. So how does this apply to an actual problem? Take a look at this example here. We're going to look for angle RSU and determine the measure of RSU. Well, if they're side by side and there's a straight line at the bottom of those angles, we know that 62 and this mystery angle here will add up to 180 degrees. So what I'm going to do is 180 minus 62 to see what that leftover angle is going to be. So we know that the mystery angle here, angle RSU, is equal to 118 degrees. Now we're trying to figure out both X and Y. If you have intersecting lines, the easiest place for you to start is the angles that are opposite from each other. So 126 and Y are opposite from each other. If they're opposite from each other, that means they are the same. So we know that angle Y is equal to 126 degrees. So how do we figure out angle X? Look at X and Y, or even look at X at 126. It's the same thing. These two angles right here, when you put them together, will form a straight line at the bottom. So side by side, in this case, we're going to do 180 minus 126, and that's going to give us angle X. So in this case, 180 minus 126 is going to be 54. So we know that angle X is equal to 54 degrees. Now, I know it didn't ask us for this angle, but if we wanted to figure out this angle, these two that are opposite from each other are going to be the same. So if this one's 54 degrees, this one will be 54 as well. Pause the video and I want to see if you can figure out what is angle X and what is angle Y. Keep in mind the two angles that we really want to pay attention to. Complementary add to 90 degrees, and then supplementary add to 180 degrees. Where I would start in this point, in this picture, would be this little box here. So if you see this little box in one of your pictures, we know that whatever's inside that box is going to add to 90 degrees. So I know if I do 90 minus 65, I'm going to get angle X. So if we do 90 minus 65, that's going to give us angle X is 25 degrees. Now there's a couple different options for getting angle Y, but what I would suggest doing is, you see this line down here at the bottom. If you see a line down at the bottom, you should automatically think, okay, everything that's above that line is going to give me 180. So all these angles right here add up to 180 degrees. We'll start by adding what you know. So 25 plus 65 plus 30, that's going to give us, let's see, if we add those together, it'll be 120. So if these three add to 120, if we do 180 minus 120, that'll give us angle Y, which is what's left over. So this is going to give us 60 degrees. You can always check your answer, because if I add these four together, I better get 180 degrees to form that line there at the bottom. Now let's look at another example with angles. This one looks a little more complicated, but it's actually one of the easier ones. Start with the angle that you're given and immediately label the angle that's directly across from it. I know we're not asked to find this angle, but it's important. So 54 and 54, these two are the same. So how do I figure out the one that's beside it? Remember, like 180 is your magic number here. If I do 180 minus 54, that's going to give me angle 3. So angle 3 is going to be 126 degrees. Now, if this is 126, I know I'm not asked to find it, but I'm going to label it anyway. What's the one across from it? This one's also 126. In a picture like this, when you have two parallel lines and an intersecting line, it's like copy and paste. These four angles are the exact same these four angles at the bottom. So this one's 54, this one's 126, this one's 126, and this one's 54. Once I got my whole picture labeled, then I would actually probably go back and fill in my information over here. It just makes things easier. I'm more of a visual person, so it makes things easier to fill it in first and then actually answer the question over here on the right. Another concept of geometry is area and perimeter. So perimeter is the distance around the outside of a polygon, and you find perimeter by adding all the outside edges. I actually would not, I know in your formula sheet there is a formula for perimeter. I do not use a formula because I think it's actually more complicated. If you simply remember with perimeter to always add the outside, so it's important to remember not the inside edges, the outside edges of a figure, then you always be able to find the perimeter. Now with area, you want to make sure that you're using your formula sheet. So keep in mind your formula sheet is found under the course information on our Moodle page. The area of a figure is the number of square units that cover up the inside of the figure. So perimeter deals with outside, area deals with inside. One thing to note is when you're doing perimeter, let's say the problem is in feet, the perimeter would stay in feet. So if it was asking for the perimeter, the units would stay the same. Area, if you notice, like when you go to buy something like carpet, is always in square units. So if I'm asked to find the area when calculating the area, if I was using feet, it would be feet squared. Again, your area formulas are found on your formula sheet. As long as you're good with plugging in the actual dimensions that you're given, you are allowed to use your formula sheet on your test. In a minute, we're going to do some practice with these. I'm going to save circles, though, for the second part of the video because that one's a little more complicated. So it says, find the area and the perimeter of the following figures. Area of a rectangle is length times width. So in this case, I would do 6 times 8, which is 48. And in this case, it would be inches squared. Now, perimeter, again, I don't really like to use a formula. That's just not my preference because it doesn't work for all shapes. I like to add all 4 sides of my figure together. So in this case, if you do 6 plus 8 plus 6 plus 8, you would get 28. And again, perimeter, your units stay the same, so this would be inches. Area of a square, what you'll do is basically it's the same as a rectangle, but the length and the width are the same. So we would be doing 2.5 times 2.5. So if we do that, we'll get 6.25 again, centimeters squared in this case. Perimeter, I'm going to add all 4 sides together. Don't forget, if you're not labeled all 4 sides, make sure you label them. Of course, you could do 2.5 times 4 sides. That would be fine as well. But I like to stick with what I'm doing for all problems, so I'm going to add all 4 sides together. And so you would get 10 centimeters. This is a parallelogram, so the area of a parallelogram, say that 5 times fast, is base times height. A lot of students struggle with determining the base and the height of a figure. If you have a figure that has a 90-degree angle, there's your base and your height. Your base is going to be at the bottom of the 90-degree angle, and your height is going to be what forms the other side of the 90-degree angle. So 9 has nothing to do in this case with my base and my height. My area would then be 12 times 8, so it would be 96 inches squared. Now, 9 does play a part, though, in my perimeter. Be careful what you add together in this case, as perimeter means the outside edges. So we are adding 12 plus 9 plus 12 plus 9. Notice I am not adding the 8 in this case. 8 is inside of that figure. It is not on the outside edges. It is not part of my perimeter. So this is going to be 42 inches. Now, trapezoid is kind of tricky in terms of the area. The first thing you do is base 1 plus base 2. Now, to determine the bases, again, look for your 90-degree angle. The ones that are opposite of the 90-degree angle here are going to be your bases. You then divide by 2 after you add them together, and then you multiply that answer by the height. So what does this look like in this problem? I would add 26 plus 8, which is going to give you 34. I would divide 34 by 2, which is going to be 17. And then I'm going to do 17 times the height. So if I do 17 times 12, that is going to give me an area of 204 inches squared. Perimeter, remember, dance around the outside. Add the outside edges together. 26 plus 15 plus 8 plus 15. Again, notice which one I did not add in there. I did not add in the 12 because it is considered on the it's considered on the inside. So this is going to be 64 inches. All right, try these on your own, and when you're ready, hit play to check your answer. In the first one, if I do length times width, I'm going to do 19 times 12, which is going to give me an area of 228. That's going to be feet squared. For perimeter, I'm going to add 19 plus 12 plus 19 plus 12. Again, I'm perfectly fine with you using the formula if you want to. This is going to be 62 feet. My area of this square is going to be 5.75 times 5.75, which is length times width. And so if I do that, I'm going to get 33.0625 meters squared. My perimeter, I'm going to add 5.75 4 times. Again, you could times it by 4 if you wanted to. That's a shortcut for a square. However, that shortcut doesn't work for all shapes. That's going to be meters. Now, area of a triangle is base times height divided by 2. So I'm going to do 30 times 12, because again, those two form my 90-degree angle here. And then I'm going to divide that by 2. And so if I do that, I'm going to get 180 meters squared. Perimeter, I'm going to add 24.2 plus 30 plus 15. Notice I did not add in that height. You never want to add in your height for your perimeter. And you should get 69.2. And then my area of my trapezoid here, I'm going to add my bases together. So 2 plus 5.8 gives me 7.8. I'm going to do 7.8 divided by 2, which is going to give me 3.9. I'm going to multiply that by my height, which is 3.6, and I get an area of 14.04 meters squared. And then my perimeter, I'm going to add 2, 4.2, 4.2, and 5.8. Again, notice I did not add in my height there, and I'm going to get a perimeter of 16.2 meters.